Hi, welcome to the review for our electrical unit in power equipment. Today we're going to cover all of our topics that will be included on the test. Please pay close attention and take notes. You'll be able to use them on the test that's following. As you recall, we are going to use both EAR or voltage is E, amps is A or current, and R stands for resistance. And remember, we're using the power of our thumb to determine what formula we're going to use. All right, pause the video here and try example 1. The explanation and solution is following. To determine the voltage, we are going to take E equals I, or amperage, times the resistance. Looking at the information that was given to us, we'll have E equals 1.4 amps times 9.7 ohms. Doing my math, I'm going to have 9.7 times 1.4. 4 times 7 is 28. Carry that 2. 4 times 9 is 36, plus 2 is 38. Drop a 0 to hold the place when I move over one spot. 1 times 7 is 7, and 1 times 9 is 9. Now I'm going to add those two products together. 8, 15, carry a 1, 13. Now I'll place my decimal. I have 2 spots behind the decimal, so I'm going to come over 2 spots and put my decimal. Don't forget to add your units. We were looking for E or volts, so I have 13.58 volts. Please pause the video one more time and solve this example. What are we looking for? Determine that. Decide if you're using EAR or pi and come up with the formula. For this problem, we're given the amperage of 4.03 amps and a voltage of 12.5 volts. So using my circle and the power of my thumb, I've determined that resistance equals my voltage divided by my amperage. Substituting in the values from my diagram, I'll have R equals 12.5 divided by 4.03. And remember, when we're using EAR, it's always voltage that goes underneath the division symbol. So I'm going to have 12.5, and I'm going to add an extra 0 because I need to move my decimal over. So here, when we're dividing by decimals, don't forget I need to make my divisor a whole number. So I'm going to move that over 2 spots, and I move it over 2 spots here, and I come up top, put my decimal in place. I'm going to add a couple extra zeros. Now I need to determine how many times 403 will fit into 1,250. In this case, it is 3 times. 3 times 1403 is 1209, and I'm going to subtract. And then drop the next digit. I have 410. 403 will fit into 410 once. 403. Subtract. And bring down the next digit. 403 cannot fit into 70, so I'm going to put a 0 here. And for our examples today and for the test following, please round to the tenths place. And I've gone out far enough, so my resistance is going to equal 3.1 ohms. For this sample problem, we are provided with the voltage and the resistance, so we need to figure out the amperage, or I for the current equals E divided by R. Substituting in the values that were given, we're going to have 14.9 divided by 2.25. Coming over to the side to do my division, I'm going to have 14.9 divided by 2.25. Once again, I need to move my decimal 2 places to make that divisor a whole number. I'm going to add 1 0, put my decimal up, then I'm going to add 2 more places because I need to go out 2 spots so I can round to the tenths place. And I need to determine how many times 225 will fit into 1,490. And when I guessed 6. 6 times 225 is 1,350. Subtract, and then bring down the next digit. And subtract. That'll be 450. So my amperage in this circuit is 6.6 amps. Example 4. A light bulb has a resistance of 2.1 ohms, a maximum current of 5.3 amps. Assuming a 12% tolerance for fluctuation, how much voltage can be applied before the bulb breaks? Please pause the video, determine what you need to calculate, and proceed when you're ready, and we'll be here with the answer. We're given 2.1 ohms and 5.3 amps. So my first step in solving this problem would be to calculate the voltage in the circuit. So I use ear one more time and the power of my thumb. E equals I, or amps, times resistance. Substituting in the values, E will equal 5.3 amps times 2.1 ohms. And I'm going to just go on the side and work out my problem. 5.3 times 2.1. 3 times 1 is 3. 5 times 1 is 5. Put a 0 down to hold my place. 2 times 3 is 6. And 2 times 5 is 10. I'm going to add those products and then place my decimal 2 places, 2 places. This circuit requires or uses 11.13 volts. Please proceed to the next slide to finish the problem. Here we found that we need 11.13 volts and we have a 12% tolerance, meaning 12% less than 11.13 volts, our light bulb will not light. And at 12% more than 11.13 volts, our light bulb will burst. So, to determine when it's going to break, which is the question being asked, we're going to take our voltage, 11.13, and we're going to multiply it by 1.12. The 1 at the beginning here is so I don't have to add that 12% on. It's going to come out and the answer will be complete as written. 2 times 3 is 6, 2 times 1, 2 times 1, and 2 times 1. 0 to hold my place. 3 times 1, 1 times 1, 1 times 1, and 1 times 1. The math isn't difficult here. 2 zeros to hold my place, and then 3 times 1, 1 times 1, 1 times 1, and 1 times 1. Now I'm going to add those products together. 6, 2 plus 3 is 5. 2 plus 3 is 3 plus 3 is 6. 2, 3, 4. 2, 1. Now I need to place my decimal. I have 1, 2, 3, 4 places behind the decimal point, so I need 4 places behind the decimal. 1, 2, 3, 4. 12.4656 volts, or rounding to the 10th place is going to be 12.5 volts, and our bulb will break. Please continue on for the next problem. To determine the total resistance in a series circuit, we have R sub T, or total resistance, equals R sub 1 plus R sub 2 plus R sub 3, and so forth, depending on the number of resistors in your circuit. So the first question is, what is the total resistance? So I am simply going to add the resistance of each circuit, 20 plus 30 plus 50. So my total resistance for this circuit is 100 ohms. Now we need to determine the total voltage for this circuit. The total voltage equals the amperage times the total resistance. So substituting my values, I'll have E sub T, or the total voltage, equals 2 amps times 100 ohms. My total voltage is 200 volts. Continuing, I need to determine the voltage drop at each resistor. So the voltage drop at resistor 1 equals the amperage times the resistance at voltage 1. Substituting my values, the voltage drop at 1 equals 2 times 20, or 40 volts. Voltage drop at resistor 2 is going to be 2 times 30, or 60 volts. And at resistor 3, 2 times 50, or 100 volts. Now, we have a quick, simple check. The voltage drop at each resistor, when they are added together, should equal my total voltage for the circuit. So here I'm just going to add 40 plus 60 plus 100, and I have 200 volts. A nice quick check that these are the same values. And I know I've done my problem correctly.